All right, howdy doody people. Got another crazy physics problem for you. So this one is kind of we're talking about relative velocity. We have a person that's walking on a moving walkway. So she's walking at her regular speed on this moving walkway. Meanwhile, the walkway is moving under her and carrying her even faster. And we want to know some information about that. So first things first, draw a picture. So here's my walkway, I guess. The woman is walking up. So for part A, we want to know how long will it take her to to finish the walkway. And we're told that she walks with a walking speed of 1.8 meters per second. And we're told that the belt, or the moving sidewalk, moves with 1.5 meters per second. And we also know that the sidewalk is 37 meters long. So following our relative velocity equation, we can solve for the velocity of the woman relative to the ground. And this equals the velocity of the woman relative to the sidewalk plus the velocity of the sidewalk relative to the ground. So I think you might already, you kind of already know intuitively what you're going to get, right? The speed of the person is going to be the speed she's walking at plus the speed of the belt. But our equations reflect that, and that's kind of what we want. So we get the velocity of the woman with respect to the sidewalk is 0, 1.8. She's moving in the y direction. Plus the velocity of the sidewalk with respect to the ground is 0, 1.5. Okay. So then the velocity of the woman with respect to the ground equals, it's 1.3. So we have 1.3 meters per second, 1.3 right here. So then the velocity of the woman with respect to the ground will be 3.1 meters per second in the y-hat direction. So then the time it takes her to do it, time equals distance over velocity. So we'll get 37 meters divided by 3.1 meters per second. And if you have a good calculator, you will get 11.9 seconds. It takes her 11.9 seconds to walk these 37 meters. Remember, she's crossing 37 meters of ground, basically. So we need her velocity with respect to the ground. So then part B asks, what so in part B, we're asking what if she turned around? Well, if she turned around, the velocity of the woman with respect to the ground would be 1.3 upwards in the y-hat direction, plus, and now she's going the other way. She's going 1.8 meters per second in the negative y-hat direction. Because remember, this time she's walking down. So then I will get negative 0.5 meters per second in the y-hat direction. So with respect to the ground, she's not moving forward at all. She's actually moving this way. Therefore, there is no time that she will cross those 37 meters. And we got that. I think it's kind of intuitive as well. You know, if you turn around and walk faster than the speed of the moving sidewalk, then you're not going to be able to go to the other side. You know you're going to overpower it, and you're going to power through it. But if we kind of do it with our relative velocity equations, everything works out pretty nicely. So you'll get 11.9 seconds and no time. That's your answer.